everyone. If you've been watching this series of videos, we've now covered looking at gases. We've talked more in detail about solids and liquids. And now we're going to look at energy and phase changes. So we know that we can convert substances from solids to liquids, liquids to gases. Okay, and so we want to look at the energy that is involved in this. So when a solid water, if you think of ice is the best example to relate to something you probably see or deal with every day. Solid water melts if you put in energy, right? You have to put in heat for it to melt. So it absorbs energy from the surroundings. So if you lay a piece of ice on the table, it absorbs heat from the room and it melts. So this is endothermic. Okay, for the opposite is true. If you have liquid water and you want to freeze it, okay, then this is an exothermic process. It goes from being liquid to solid. Okay, so the amount of energy that is needed to melt a gram of a substance is called the heat of fusion. Okay, so all substances have a different heat of fusion, okay, but we are mainly going to be looking at water. Okay, and the heat of fusion of water is always 79.7 calories per gram. Okay, and so all you really need to see here is that heat of fusion is dealing with how much energy it takes to melt. So this process right here. So if you melt something, you go from a solid to a liquid. So if we had water and we had ice cubes that melt, just like I was talking about just now or a few minutes ago. So how much energy in calories is absorbed, because we know it's endothermic, when 50 grams of ice cubes melt? Okay, the heat of fusion is 79.7 calories per gram. So like always, write down what you're given and then look at how you could do a converting problem and cancel your units. Okay, so sometimes students get tripped up with these, but they're really just, you're given the heat of fusion and you're given everything you need, and it's just a simple one-step problem. So you have 50 grams and you want to know calories. All right, so right away when I look at my problem here, I'm like, okay, I've got grams that could cancel, and that leaves me with calories. Okay, so you have two conversion factors. So you've got 79.7, that should be a 7 over here, per 1 gram. And or you could flip that over, just like always. We've been converting. If you've been watching this series of videos through the semester, we've been converting like this constantly. So all we have to do is take our 50 grams, okay, if we write that out, we know grams has to cancel. So we're going to have to pick this because grams is in the denominator. So that's exactly what we do. Our grams cancel. So we take 50 times, since we have 50 grams and there's 79.7 calories per gram, then you do multiply 79.7 calories times 50. Okay, and we get 3,985, but we need 3 sig figs, so we have to round that to 3,990 calories. So all you have to do is multiply. Okay? Now if we convert a liquid to a gas, so this is called vaporization. And once again, just like melting, this is endothermic. Liquid has to absorb heat in order for it to become a gas. Okay? The opposite is true for condensation. This is exothermic. You're going from a gas to a liquid. Okay? The amount of energy that you need to vaporize, so looking at this here, okay, vaporization is liquid to a gas, whereas fusion, we were going from a solid to a liquid. Okay, so vaporization of 1 gram of a substance is called heat of vaporization. And so substances have values for this, just like they did for heat of fusion. Okay, and then the last two to look at here, if you convert a solid to a gas, okay, this is going directly from a solid. Not all substances can do this. It bypasses the liquid phase and goes straight to a gas. This is called sublimation, and this is endothermic. And a substance can do the reverse and go from a gas directly to a solid. Okay, and so this is called deposition, and this would be exothermic. Okay, so here's a table of all the ones we've looked at. So a solid, melting is solid to liquid, freezing is liquid to solid. So that's the main thing. Vaporizing is liquid to gas. If you condensate gas to liquid, just like condensation builds up on your windows or outside. Sublimation is unique, going straight from a solid to a gas. And then deposition is straight from a gas to a solid, so the opposite. So they're really, the opposites of each other. One's endo and exo for each of these. All right, now we're going to practice some of the problems. So we're looking at heat of fusion. So just a reminder, if you go back and look at your heat of fusion, okay, heat of fusion, all the way back to the beginning here, oops, okay, is the amount of energy to melt 1 gram of a substance. So we are looking at melting a solid to a liquid. Okay. So we have the heat of fusion of water, 79.7 calories per 1 gram, and we want to know how much energy is released when we have 42 grams of water. So all we do, okay, this, if you want to write it out like this, you can. That is our common relationship, our conversion factor. So when we take that and multiply it, we get 3,347, which we round up. We need 3 sig figs, so it rounds to 3,350 calories. Okay, I wanted to add another practice problem just so we do one with heat of vaporization. So the heat of vaporization of water is 540 calories per gram. So you work this just like the heat of fusion. And so we're looking at, we want to know how much energy and calories is absorbed when we have 14 grams of water. So once again, we use our value here, and this is out of 1 gram. So we get whoops, 7,560 calories. So same basic idea as with heat of fusion. This is just with heat of vaporization. So we're converting a liquid to a gas in this situation. And like I said, for my class anyways, you'll be given these heats of vaporization. So really it's a one step, just multiply and find the energy and calories, and that's it. All right, thank you.